Hello, welcome to creating your own singing voice synthesizer, overcoming data collection challenges. Some agenda for today. I want to go over the motivation for this talk, a little bit of brief history of singing voice synthesis, some open source options we have to do this, as well as tools and techniques to building a personalized data set and/or voice bank. A little bit about myself. My name is Matt. I'm currently a master's student at Queen Mary University of London, and particularly I'm researching deep learning applications for music and music production. Previously, I've worked at Qualcomm as well as Make as an audio software engineer, and a lot of the material from this talk was inspired from my work at Make. Feel free to connect with me at the links below. I've posted my slides on my Twitter. So the motivation. So today, my goal is to inform both researchers and industry professionals about the choices for custom singing voice synthesis, as well as inspire people to build more public data sets and systems. And the key points here are custom, meaning any voice. It could be your own, it could be someone else's, and public. We want this to be open for anyone to use. So what is singing voice synthesis? Well, traditionally what it means is we take a score, that is notes and rhythms, as well as lyrics, and we have some kind of system that could synthesize a human singing voice based on the lyrics according to the score. And I do want to emphasize a few other speech and voice singing technologies that it's not. It's not the same as text-to-speech or singing voice conversion, which is behind some of the AI covers you might have heard of, voice cloning, speech-to-singing. These are all related speech and singing technology, but they're not the same. And there's some unique challenges that we face in singing voice synthesis. So I'm now going to show a demo of one of these systems in the wild. This was a recently trained model from Porter Robinson. They worked with Vocaloid and created a somewhat robotic style voice that reflects some of the music in some of the voices in Porter Robinson's music. Yeah, so I'll show a demo of that in, the model is called OpenUtau, and this is a demo song that they made. So now I sing for you till I can't talk. I've been teaching myself to speak for when the music's not enough. I'm gonna be just like you and never stop. But since I'm made from you, do you think I could be someone like you? Okay, so now a little bit of history. So in 1962, you might be aware of the famous experiment in Bell Labs. It was using the folk song Daisy Bell. They had a physical modeling, speech, and singing synthesis engine that they were working on, and they synthesized the short song. It's been popularized in movies as well. In the 80s, a lot of people were working on formant synthesis as a filtering kind of approach for singing voice synthesis. IRCOM famously made their chant system, but there were other players here working on formant synthesis. In 2007, Yamaha, in collaboration with UPF, created the first Vocaloid product. This was based on concatenative synthesis, and the way this works is we're stringing together sounds such that it sounds like singing. In 2010, Sinsy came up with a hidden Markov model process. This is one of the first popularized machine learning approaches for singing voice synthesis. And nowadays, there's been a few products that come out, such as Yamaha's update to their original Vocaloid called Vocaloid AI, and this uses a deep neural network to do the singing voice synthesis. So some of the products today, we have the previously mentioned Vocaloid, there's Chevio, there's Dreamtonic Synthesizer V, and the way they work is they provide you with this kind of editor, as seen here. You can select, there's a bunch of voice banks you can select from. That's their names for the voices, and there's many different languages. The way it works is you can drag, just like in a DAW, you can drag notes and type in lyrics, and it will sing those lyrics according to the notes and rhythms that you've typed in this piano roll. So you must be thinking, okay, if we wanted to do a custom solution, it should be pretty easy, right? We should be able to create some kind of data set of our voice or someone else's voices and then import them into one of these products and they can figure them out, right? Well, not so fast. It turns out that none of these products have some kind of this capability where you can import a custom data set to use in singing voice synthesis. And this presents us many problems for customization. So if we want to have a solution that uses custom voice, we need both a synthesis tool and a data set. And there are some open source data sets or voice banks that are available online. However, they tend to be very limited, and especially if you're trying to do a language outside of Japanese or Chinese and even English, there's not that many examples. So there's really a big problem if you want to use some kind of custom singing synthesis in a research or commercial product. And even there might be some companies that have proprietary data sets that we can't use in a similar commercial or research setting. So there are a few open source synthesis tools that I'll mention that are pretty powerful. The first one I'll mention is the Utau and its open source successor, OpenUtau. These are both based on the concatenative synthesis technology. And if we were trying to create a data set for this tool, the way it works is we'll have to sing particular sections of sounds that they tell us to sing. We'll label those sounds. The annotations are things like start time, end time, things like that. Usually we don't need too much data for this. Less than an hour can have some pretty good results. And then once we have all this data, we're pretty much ready to go. These tools offer a really nice GUI that we can just import our voice bank, as they call it, straight into it, and it's ready to go and usable. It's been around for quite a long time. As I mentioned before, the technology is a little bit older, but that's also maybe some of the disadvantages. As we're seeing newer, maybe deep neural network models come out, this kind of technology is a little bit old at this point, but it does work quite well. The two other products I'll mention today are both based on deep neural networks. They're both recent products. There's NNSVS and DiffSinger. The way to collect the data for these is a little bit more tricky. We need to have singing, and then we need to go in and label the phonemes. So these are the individual sounds our mouth is making. And this is significantly harder than doing the data collection for Utau and OpenUtau. Also, we need usually decently more data than we would for the concatenative synthesis technologies. And we also need to train the models. Unlike the concatenative synthesis, these are deep neural networks, so they need some kind of training time, and that can depend on our compute resources, which can get quite expensive. The good thing about NNSVS in particular is it does have some community guides and voice banks. And so there are some resources out there we can use to do the system. It's also modular, meaning that it's been created in such a way where pieces of it can be updated over time as more models come out. However, at least at this point in time, NNSVS's quality seems to be somewhat comparable to Utau and OpenUtau, meaning it's quite a lot of effort to get a similar notion of quality. The other system I'll mention is DiffSinger. This one uses diffusion, which is a newer deep neural network approach to doing generation. And this one is great, but it does require usually more data to get good quality and a longer training time. And it tends to be a little bit harder to train, and it can be more unstable. And unlike NNSVS, there are fewer resources, fewer guides and tutorials about how to use this particular tool. And also in general with deep neural networks, as you might know, it can be hard to know what to do when it is not working correctly. It's harder to debug, as maybe we heard from our talk earlier today. I would also like to mention a few other research projects that have come out recently. These are all based on deep neural networks. There's MuseKits, Unison, VISinger 2, Natural Speech 2. These are all great projects. However, they're not really usable by the public. There's no real guides or notebooks or ways to train them with their own custom data set. They're all basically in this research paper, research stage, and they'd really benefit from community or commercial support to make them more usable by the public. So I'll first go through the method of how we create a data set for the concatenative synthesis technique. So this is for our OpenUtau and Utau systems. Basically, the first thing we need to do is we need to select which type of voice bank we're going to do. There's choices like CV, which is consonant vowel, VCV, vowel, consonant vowel. There's a bunch of them. I've pointed a link to the rest of them there. And the choices is really a trade-off between the quality of the outputs we want as well as the amount of data we need to sing. As well as the language we want to sing in actually does restrict us to which voice bank we choose. So once we've chosen a voice bank, we can find a rec list, which is basically just a list of items to record. It's based on the type of voice bank we've selected. And the process is quite straightforward. We'll get this rec list. We can use a tool like Oremo and Audacity to record a bunch of these samples. We'll do what's called autoing, which is the annotations that I mentioned previously. And this is like labeling the start time and end time and things like that. We can use setparam as a great tool for that. And then we create some small metadata files, and then we're pretty much ready to go. We can import this into the OpenUtau GUI, and it's ready to be used as a custom singing voice synthesis voice bank. I've provided a link to a tutorial, as well as some public and free voice banks there. Now, for the deep neural networks, as you might imagine, it's a little bit trickier. The real main requirement is to have high-quality singing data, which sometimes can be really hard to get. And then the next thing we need to do is go in and label all the phonemes and the phoneme durations. This can be quite challenging as it requires really precise timing and to make it work well. There are tools like VLabor and Prot that do make this significantly easier. But the first thing we need to do when labeling is we need to determine which phonetic alphabet we're using. There's choices like ARPAbet, IPA, Pinyin, depending on which language you're trying to use. There are a few pre-labeled data sets out there. The best one that I know of is OpenCPOP, which is a Mandarin Chinese data set. But there's very few of these that have these phonetic timings that have been labeled. And then we need to also add some kind of musical score that dictates the notes and rhythms from previously. There's a tool that I've linked to that will do this from your data set, and maybe you can correct some of the errors, but this also is a little bit more challenging to do. I've provided a link to guide on how to do this, but also it's nice to know that this guide also has a link on how to use our finished trained model in the OpenUtau GUI, so it is nice that we can do some cross-importing there. There's also potentially a way to do this automatically, because you might be thinking this sounds really tedious. Labeling all these phonemes might take forever, and it really can. There is a link here, and I'll talk more about this process in a minute, but it's potentially possible to do some of this process automatically. This link will only do it for Chinese, but it could be adapted to other languages. And then the next thing we need to do is we need to do the training. So once we have our data set, we need to load up the model and do some training. Hopefully we have some kind of GPU, otherwise it might take a very long time. I provided a link to a couple notebooks, but one for the NNSVS as well as DiffSinger. And another important thing to note is it is possible to warm start with the pre-trained model. So what this means is if we have a already trained voice that's similar to the voice that we're trying to get, that's in our data set, if we warm start the model with the initial voice, it will likely train much faster to get to converge on the newer data set. So especially if you're trying to do a lot of these or in a batch process, it's probably a good idea to be using this warm starting to save you a lot of compute time. So as I mentioned previously, maybe it's possible to do some of this labeling automatically. And there are some caveats to this process that I'll mention, but basically the idea would be is if you had a data set of mixtures with different instruments in them, perhaps what we could do is you could do some source separation with a tool like Demux, extract out the vocals. Maybe from there we'll do some segmentation, remove the silences, split it into smaller segments. We can use a tool like PyDub to do that. We'll need to extract the lyrics. There's a tool called Whisper that does this really for speech, but it sometimes can work also for singing. Once we have the lyrics, we need to do this phoneme extraction and alignment. There's a tool called Montreal Forced Aligner that does this. Again, it's really made for speech, but it sometimes can work decently well for singing. And from there, we'll get our phonemes, phoneme timings, and audio files. But as you might imagine, there's probably a lot of errors that get propagated in this process. And I wouldn't necessarily recommend doing this process, at least initially, because of the quality issue, as I mentioned before. We really need both high-quality audio and high-quality labels to get the best output from our deep neural networks. But maybe in the future, this could be a process that you implement, or at least you do pieces of this if you have already parts of this ready to go, and this would speed up the creation of a new voice bank, maybe for an end user. So how do we put this in a real system? Well, from the beginning, we need to get something that takes the score and the lyrics and outputs the singing voice. And from the models that I've presented before, we still don't have a way to take our score data and the lyrics data and convert it into a format that our singing voice synthesis model accepts. So we will need some kind of data processing, maybe like music XML conversion or doing those kind of editor features, maybe some kind of phonemizer, some graphing to phoneme that'd be converting the lyrics to the phonemes. And then if we're doing the concatenative synthesis, we need some kind of resampler method, which will be how do we string together the sounds to make the singing. But perhaps the easiest solution if you're building this into a product would be just to build on top of these open source solutions that already have the data processing built in. They already have scripts and tools that'll do this for you. I do want to spend a minute on ethics because as we know, generative AI is here, and there is some precedent maybe for stealing voices. is wrong. And so I think it's important to mention that if we're trying to use this process on maybe someone else's voices or a famous person's voices, it is a little tricky. And it's possible that there might be some litigation based on these processes, and maybe we're seeing other tools and similar processes coming up with these voices that might be a little bit gray area. Right now, there's really no consequences, but even user-generated content might not be immune. There also seems to be some kind of disconnect between what the users believe about the ethics as well as the developers. Perhaps the users might have one opinion or one thought about how developers are creating our tool or what their concerns are, and developers for these tools are maybe not or more unsure about what the users are thinking or wanting, or how to bridge this gap between what people actually think is going on behind the scenes and what is actually going on behind the scenes. And I think it's important, perhaps, as developers, to explain this process as much as possible to reassure the public or to provide some more context about what we're doing. And perhaps there's a really easy solution for this. As developers, perhaps we can partner with artists to get some of the high-quality data that I mentioned before and have some kind of profit-sharing scheme. Maybe this could be used for demos, multilingual tracks, or fan engagement tools, some kind of licensing scheme. In general, we'd like to maximize the outputs of artists instead of stealing them. So what now? Well, in general, we need more things. We need more research projects. We need more data sets, especially in underrepresented languages, and almost every language is underrepresented. We need easier tools to train data sets and import them. It'd be great if we could have some kind of standard format, because as maybe new research projects come out, we could just easily import our already created data set into this new research project and see how it sounds. And also democratize existing projects. There's plenty of work to be done on the previously mentioned research projects that can just make it significantly more easier for the public. So my challenge for you is maybe try creating a model or voice bank with your own voice and see what amazing results you can get. I'd like to also thank a few people who helped with this talk, and I have some references. Thank you.
Do you find that people that use this technology want to use it more as a collaborative tool or as a standalone, I'm going to replace the singer for everything kind of tool?
I've seen both. I mean, I don't know. It seems this kind of technology has been around for a while. As you see, it's mostly been restricted to people who have been hobbyists. They've been, people who've just been experimenting with creating voices or singing and just trying to see what kind of results they get. But I think recently there's been more interest in using these tools to maybe, because there's a lot of projects making this super high quality, it's been more possible to maybe replicate the sounds of artists. And I think it is at least pretty possible to maybe take some artist work and create a synth out of it. But I think it traditionally was not like that, and it's currently moving more into maybe possibly taking artists' voices.
Hi, thank you for the great talk. Do you have any ideas or comments on how to close the gap between the research that's coming out with kind of, more of a DNN or AI-focused method? Like, do you think the onus is on having the academic space be the ones to take on these open source, kind of like scaling up and transition into actually having repos and notebooks, et cetera? Or do you see that as companies' responsibilities, or, where do you see that progress happening?
Yeah, it's a really good question. I mean, at least from what I've heard, it seems like the academic institutions are quite under pressure just to put out a lot of these research projects in the first place, and they really don't have the resources necessary to spend on productionizing these code, and we've had to rely on maybe third-party people on their own time creating these notebooks. I personally believe that, at least in this current situation, we just need maybe more, at least good people from industry or people outside of the academia creating these kind of production environments. Because I think, from the academic environment, sometimes it's really hard to take your paper that you've thrown the code together and turn into a product. But I think in general, there just needs to be more collaboration. I mean, you know, that some industry person will put out this great paper and great code, and then just leave it and move to the next project. So I guess that's my general recommendation. But I think the onus is more on the industry for now.
And maybe one quick comment. This may sound naive, but have you looked into using like old karaoke machines as a format for timing information and
Yeah, actually, so there is a data set out there called the Dolly data set that actually has a bunch of this data of like people singing to karaoke machines and doing this. I think currently the biggest problem with that is just the quality. I mean, if we want to get high quality singing data, usually people either singing on their phone or some bad microphone tends to not be that great. But in terms of the timing, there's a lot of stuff there, and there have been people who've tried to do singing systems based on that kind of karaoke system. That's a great point.